chapter about linear functions and their applications, and he's going to say something about functions in general, mathematics quantity, mathematics correspondence, something about Descartes' coordinate system, and finally applications of linear functions as a special case in
First of all, I will say something about dependent mathematical quantities and one of the most important rules. If we know the value of one quantity, we can determine the value of another quantity. This law is considered as a rule by which the different values of one quantity called the independent variable are given to the different values of another quantity called dependent variable. A special case of dependence between two dependent variables is called linear dependence. Example, if two parallel sides are extended by 1, we get a rectangle with sides a and a plus 1. The relation between the perimeter of that rectangle and its side's length are presented by a quotient of perimeter equal 4 times a plus 2. So, if we know the length of the short side of that rectangle, we can calculate its perimeter. In this case, we say that the perimeter of the rectangle is linearly dependent of the length of the short side. Linear function graph is presented in Descartes' coordinate system, and now let's say something about this itself. In 1637, the French mathematician and philosopher René Descartes introduced the coordinate system in the plane, and this is called by him. Descartes' coordinate system. The value of independent variable x for which the value of the function is 0 is called zero of the function. On this graph we have two different functions. In this first function, y equal 2 times 6 minus 1, 0 is at point 0.5. On the second one, the function y equal minus x plus 5, 0 is at point 5. Drawing the meaning of the linear function graph. Graph of the linear function y equal kx plus n, where x is real number, is a line. Since the line is determined by two different points, to draw the linear function graph, it is enough to determine 2 points that belong to it. The point M belongs to the graph if its coordinate satisfies this quality. Example, to draw the linear function y equal x plus 2, it is enough to determine two different points that belong to the graph. We have two ways to determine the graph. First way is that when the function is given in the explicit form, it is the easiest way to choose the first two coordinates of two different points, and then determine the other corresponding coordinates. For example, for x1 equal minus 1, we get the y1 equal minus 1 plus 2 equal 1, and for x2 equal 1, we get y1 equal 1 plus 2 equal 3. So the line is determined by this and these points, and it's the graph of the linear function y equal x plus 2. Of course, we can determine the several different points that belong to the graph. All those points should be collinear because they belong to the same graph, to the same line. Second way is that to draw the graph of the linear function y equal kx plus n, where we notice in everyday life. These are some examples for the application. This is example of the price of the taxi drive. The price of the taxi drive in Belgrade is calculated like this. The start is paid 100 dinars, and every following kilometer is paid 50 dinars. In Novi Sad, the price is calculated in this way. The start is free of charge, but every next kilometer is paid 100 dinars. How many kilometers will the customer be driven for the same price? This is the table of the price. After the first kilometer we get this price. second, third, fourth, and fifth kilometer. This is the graph of this two linear function. The intersection of these two linear function represents the solution of this example. That means that after 2 kilometers, customer will be paid 200 dinars. These are also examples for linear application of linear systems. This example can be solved by using the system of the linear equation. Every system of the linear equations can be presented by the graph, where we can see its application in everyday life. Two angles are supplementary. One angle is measures 30 more than the other. Find the measure of both angles. And second example is that Anna's and Maria's age together equal 5. Twice Anna's age is 1 year less than the Maria's age. How old is each person? As you can see, the solution of example for years is this point. Anna have 2 years and Maria have 3 years. Now we can conclude this. Based on all these examples, we can conclude that numerous problems can be expressed by the linear equations or by the systems of the linear equations. Since the system can be solved using the graph method, a linear function for the graph is a line. So the intersection of these lines is the solution of that system or problem, as I explained on example. You can apply linear functions or system of linear functions everywhere in your life. For example, in physics, techniques, and chemistry. Thank you for your attention.